All right, bless you. Yesterday we talked about slopes, correct? But we're not just going to learn about slopes. You did this in Algebra 1, I'm sure. Maybe a little bit in pre-algebra. Okay? So we know a slope is m, correct? And m is the change in y over the change in x. Do you know what that means when I say the change in something? It's the difference between the two things, right? So it's y2 minus y1 over x2 minus x1. Now I put the 2 first because books usually do that, but does it really matter which one you subtract? It doesn't matter as long as you subtract the x's and the y's in the same order. Does everybody hear me? So as long as you subtract the y's in the same order as you do the x's, then you're okay. It doesn't matter that you have to go x or y2 minus y1. Okay, it doesn't make any difference as long as you subtract them both in the same order. So that's the slope. And it does tell you something about a line. All right, it tells you how slanted that line is. But what if you wanted to know a little bit more than just how slanted a line is? What if you wanted to know how slanted it is and where it goes through? So for instance, something like this. All right, like how far up and down is this? Because watch, this right here is a different line than this right here, isn't it? Now, they have the same slope because I copied and pasted that line. So they have the same slope, okay, but what do? They go through a different point on which axis? On the y-axis, don't they? Now, they actually go through different points on the x-axis as well. But for some reason, the formula that we usually use really doesn't have anything to do with the x-axis. Okay, the one that we're most familiar with, and there are more than just one equations of a line, all right, but the one that we're most familiar with deals with two things. It deals with the slope of the line, and it deals with this point right here. Okay, that point's very important on these lines, and you remember this from Algebra 1? What do we call that point? Right, the y-intercept. Again, there are x-intercepts. Okay, there's an x-intercept right here, isn't there? And this line right here has an x-intercept. It crosses the x-axis right there. But on the equation that we're going to be more familiar with, we're going to use most of the time, we don't really care about the x-intercept for right now. Okay, there will be a time where the x-intercept is kind of important, but for right now, we're not going to care about it in this first equation we're going to talk about. All right, so we need an equation that relates those together, and I'll just show you what it is. And I'm sure you know what it is already. Y equals, remember what that is? Mx plus b. Good. Very familiar, right? If you had Algebra 1, you definitely did some of this stuff. So y equals mx plus b. Now, the b. Now we know what the m is, don't we? The m is the slope of the line. The b is the y-intercept, right? And I'll just shorthand it, just y dash int. That's the y-intercept. You ever wonder why b? Why did they pick b for y-intercept? Isn't that weird? Because usually what they do is this, that the A represents the x-intercept, and then B represents the y-intercept. All right, so they use B for the y-intercept. All right, but we don't really have an equation. I should say this. We don't use the x-intercept really in this equation right here. We just use the y-intercept and we use the slope. So this tells you a lot about that line. It tells you everything you need to know. So if I told you that the line goes through a certain y-intercept, certain point on the y-axis, and I told you what the slope is, you should be able to graph it very easily. All right, shouldn't be that hard. All right, so there's let's name the thing. So since we have a slope and since we have an intercept, guess what we name this form? The slope-intercept form. So it's called the slope-intercept form of the equation of a line. I'll write that whole thing down there. Of the equation of a line. It's called equations of a line. Or lines. Equations of lines. Alright? So that's the slope-intercept form. It's probably the most familiar one. It's the one it's really pretty practical. Alright, there are other equations. There's probably about 3 or 4 that I know of off the top of my head. But we're only going to learn 2 of them. Okay, this is the first one. This is the one that you probably use more than anything else. Alright, it's not the only one, but it's probably the most familiar one. The slope-intercept form. Y equals mx plus b. You've all heard that before, am I right? Okay, good. So, let's do this. So they're going to ask you, this is pretty easy.
Mr. Hamrick?
Yes? She can never hear me. Okay, here's an example. Put EX for example. It says, this is right in the book, it's on page 196. It says, write an equation, all right? Write an equation in slope-intercept form, okay? Well, so far, that's the only form we know, right? So, good thing. Of the line with a slope of 3. So, what I'm going to do is I'm going to say m equals 3, slope of 3, and a y-intercept of negative 2. Oh, my word, this can't be any easier. Of negative 2. All right? You could do that, yes. Yep, absolutely. I probably should have, but, oops, get rid of all that stuff. Yeah, you could just write b equals negative 2 if you wanted to. It makes it a little bit easier. So what is the equation of a line? Slope-intercept form, y equals mx plus b. All right. Now, this x and y just stays x and y. All right, so we don't put any numbers in for this x and for this y. Not yet, anyway. So we just put y equals, and basically we just stick the number in for m for that, and whatever b is, we put in for that. So what is this? 3x. Yeah, you could put plus negative 2, but what's plus negative 2? It's minus 2. Now, if you were to graph this thing, it should be pretty easy to graph, shouldn't it? Yeah, that's the equation of a line right there. That's in slope-intercept form right there. Okay? If they ask for x, they're not going to ask for x. They just ask for whatever the slope-intercept form is, and that's what it is right there. If you were to graph this, let's graph this. Now, you don't have to have graph paper. If you like to use graph paper, feel free. All right, I'm not going to require you to use graph paper on this, but just make your graphs fairly easy. So watch, negative 2.
Thank you.
So you put the y-intercept at negative 2, and what is this? This is the what? The slope. And what is slope? Slope is rise over run. What's the run here? It's 1, isn't it? So watch what we're going to do. Just give me a second. Let me finish this problem, then you can go. Watch. So 3. 1, 2, 3. That's rise 3, and then run 1. Put a little dot right there. What do we do with those 2 dots? Connect the dots. That's right. So it looks like this. Now, don't just stop from one dot to the other. I've seen people do that. They just put a little line segment between one dot and the other. All right, make sure it goes all the way through. All right, and there you go. There's your graph. So we graphed it, we wrote the slope-intercept, and you're good to go. All right, let's do another form. Okay, so slope-intercept form was one of them, and then we have another one called the point-slope form. Point-slope form. So on this problem right here, yeah, we'll do it in a second. Let me backtrack a little bit. Look at this right here. Look what they gave you. They gave you a slope and they gave you the y-intercept, didn't they? All right, so it's nice and easy to use the what? The slope, right? Intercept form. So if they give you a slope and they give you a y-intercept, it's perfect to use the slope-intercept form. But what if they give you 2 points and a slope? All right, then guess what we're going to use? We'll use the point-slope form, okay? Actually, they only need to give you 1. They don't even have to give you 2, okay? If they just give you 1 point and a slope, okay, you can actually graph the thing and you can write it into the formula. All right, so here is the point-slope form. It's y minus y1 equals m times, in parentheses, x minus x1. Now, the y1 and the x1 are actual numbers that we're going to throw into this. The m, of course, is a slope, just like it was before. The x and the y, without the 1 underneath of it, okay, they just stay x and y. Is that all right? Okay, so here's an example. They give you a slope. This is on the top of 197. They give you a slope of negative 3/4. And they give you a point that line goes through. All right, they just give you 1 point that line goes through. And I'll just put the ordered pair right here. And that point happens to be negative 2, 5. All right? Now look, they didn't tell you what the y-intercept was, did they? So it would be a little bit tough to find the y or the slope-intercept form of this. Now I will show you in a second that you can still use a slope-intercept form with this if you wanted to. All right? But for right now, let's just do the point-slope form. All right, so that we're going to do the point-slope form. Why did we use the point-slope form given this? Because they gave us a what? A point and a slope. Okay, so we use the point-slope form. It's kind of nice, isn't it? All right, so let's plug some stuff in. Now, what are we plugging it into? This thing right here. What about this first y? What did I just say about that? That just stays y, right? It just keep it y. Minus y1. What's our y1 here? Our 5. That's right. This is the x1, and this is the y1. Everybody see that? The point that they give you is the x1 and y1. That's what you're going to plug into here. So it's y minus 5 equals m. What's my m? Negative 3/4. Put a parentheses. This x just stays x minus x1. What's x1? Negative 2. What's that minus negative 2 going to do? Just becomes positive. So really, that's it. That's the point-slope form. You can just keep it like that. If they ask you to put it in point-slope form. If they ask you to put it in point-slope form, I would keep it just like this. Pretty simple, isn't it? Just plug stuff into a little formula, no big deal. You hardly had to do anything with that. But they're not always going to say that. They may give you a slope and give you a point, but they may say, write your answer right in slope-intercept form. Intercept form. Okay? What if they gave you a point and they gave you a slope and you had to write it in slope-intercept form? Well, you could still use this. Watch, I'm going to continue this. Let's go a different color. I'm a little blind from all that purple. Look at this. How in the world could I take this and write it into the slope-intercept form? Well, what is slope-intercept form? It's y what? Equals mx plus b. So really, what do I basically have to do? Just get y by itself, don't I? So look at this. How do I get y by itself? Let's get rid of that 5, okay? But you know what I might want to do, though? Might want to go ahead and distribute this negative 3/4 through here, wouldn't you? Okay, so let's do this. Let's do a little math right here. So I'm taking this, and I'm throwing it down to here. So let me just rewrite the whole thing. Might as well. Nah, let's just distribute right now. So what do we get? Negative 3/4 x, right? Minus, 3/4 times 2. Can you do that in your head? So what happens here? That's 2, right? That's 1. So what's 3/4 times 2? It's 3/2, isn't it? So it's minus 3/2. Now I'm not going to make it a mixed number, okay? Keep it improper. I think it's way easier working with improper. Is that in slope-intercept form yet? No. It's kind of close though, isn't it? What's the only thing I really have to... The minus 5. Yeah, if I can just get rid of that minus 5, then it's going to be in slope-intercept form, isn't it? Alright, so how do I get rid of that minus 5? I add a 5. And I add a 5 to this over here. So watch what I do. Now look, you could have gone mixed number here if you wanted to. Alright? I would rather not do that. If you're going to add a 5, you're adding it to 3/2, aren't you? What can I make that 5 into? Well, 5/1, but I want this denominator to be a 2, so right, I'll make it 10/2. Isn't that the same thing as 5? Everybody see that? Why I made it 10/2? Because I want to add it to this. So negative 3/2 plus 10/2 is 7/2. Now, you could have done that with mixed numbers if you wanted to. It's not like you couldn't do it. Okay, but I would rather you get used to keeping things improper. All right? You could just keep it like this. Okay, that would be in slope-intercept form. Now, if you wanted to graph it, what would you probably want to do to that 7/2? If you were actually to graph it and find out where it is. I would make it, well, you could make it a decimal, but I would make it just a fraction. So what would that be? 2 goes into 7 what? 3 times, and then what? 1/2? 3.5, right? But I would be fine. If all they said was write the equation in slope-intercept form, you could just keep it exactly like this. But if you were to graph it, you'd probably want to write it 3.5 because, 7/2. If I said, oh, go to 7/2, you're like, oh, 7/2, what's that? What are you doing in your head? You're always converting it to a mixed number, aren't you? Right? So, sure, you could take this, make it 3.5. All right? I know, everybody wants to change things to decimals. I understand that you do, but try to keep things fractions. When they're fractions, keep them fractions. Okay? And there's reasons for that. There really are. Okay, what if we did this? What if I gave you 2 points? Now, we don't have a formula, at least not here anyway, but we can kind of make up our own. We can kind of do this on our own. What if I gave you 2 points, and I didn't give you a slope, but I wanted to find the equation of the line that goes through those 2 points? Okay, this is what I'm giving you. I'm giving you 2 points right here. Actually, they made this one kind of easy. If I give you 2 points, I want you to find the equation of a line. Equation of the line. Because 2 points, if I connect those 2 points, I'll get a line, won't I? Alright, so I want to find the equation of that line, which means I want to find its what? No, not distance. Distance didn't have anything to do with the equation of a line. The what? The slope and the y-intercept. What do we know right now? Look at those 2 points. Now, this isn't true with every single problem, but on this particular one, I see something right off the bat. Do you see it right off the bat? Out of those 2 things, slope and y-intercept, what do you see right now without doing any math at all? What do you think? On the y, no, not the x-axis, on the y-axis, that's right. 0, 3. See, she recognized that 0, 3 actually lies right on the x-axis, or now I said it, the y-axis. Doesn't it? Because look, this point 0, 3, 1, 2, 3. So what's your y-intercept right off the bat? It's 3, isn't it? All right, so just by, now, does that happen with every single problem? No, because it's not always 0 something. But on this particular one, that made it pretty easy. So that's my B, isn't it? So the y-intercept is just 3. What else do I have to find in order to get the equation of a line? We're going to put it in the slope-intercept form, by the way. So I figured out what the y-intercept was. Now I got 2 points. What else do I need to figure out to be able to find the equation of this line? The slope. That's right. Well, I got 2 points. Do I know how to find the slope between 2 points? Sure. We learned that the other day, didn't we? Yesterday, day before, whatever it was. Okay, so yeah, let's go ahead and find the slope. So the slope is the change in y over the change in x. So subtract the y's from each other. So it's 3 minus negative 1. Subtract the x's from each other. That's 0 minus negative 2. That's 4 over 2 equals 2. So the slope is 2. So look, I needed 2 things, didn't I? I needed the y-intercept and I needed the slope. Now I can put it all together into my little equation. So how do I write this then? Y equals what? 2x plus 3. And that's it right there. That's the equation of the line that goes through these 2 points. Right? You don't really have to graph these things, do you? I'm just doing it kind of for fun right here. But you don't really have to graph these. But that's what the graph would be right there. Okay, what's true about it? It's got a y-intercept of positive 3. What's the slope? It's 2. 2 over 1. So if I rise 2, 1, 2, I run 1, boom. It hits right there, doesn't it? See that? Let's do another one, okay? We'll be done after this one. Let's do this real quick. About 3 minutes left or so. We'll go with this puke green color. How about that? It's kind of nice green, isn't it? Forest green. Can you read that all right up there? Well, it looked kind of puke green on the color scale, didn't it? But that's all right. Let's do this real quick. Well, I want to find the equation of a line. So the first thing I'm going to do is I'm going to find the slope. Because I don't know what the y-intercept is here, do I? Because it's not 0 anything. So first thing I'm going to do is find the slope. Let's do that very quickly. So it's 4 minus negative 4, right? Change in y. Change in x, negative 7 minus 9. That's 8 over negative 16. What is it? Whoops, not negative 2. What is it? Negative 1 over 2. Did I do that right? It's negative 1/2. That's the slope. Let me finish, because I don't have much time. Now, it's negative 1/2. What in the world are we going to do? Well, now look. We could, if we want to, use the point-slope form. Because now I know a slope, and I know 2 points, don't I? I can use either one of these points. That's what's interesting about this. So if you want to use the point-slope form, let's go ahead and do that since we learned it. Let's use it. There's another way to do this too, but we can use this way. Let's plug some stuff in. Which point do you want to use? Do you want to use this first one or the second one? Let's use the first one. Nobody said anything. So we'll use the first one. So this is kind of like my x1, and this is my y1. You see it? So y minus y1. What's my y1? It's 4. Equals m. I just found it. What is it? It's negative 1/2. Times x minus x1. What's my x1? Negative 7. And now, this looks very familiar, doesn't it? Looks like what we did just earlier. So I'm going to go y minus 4. Let's distribute the negative 1/2. Negative 1/2 x. This is a plus, right? So that's minus what? 7 over 2. How do I get rid of the 4? Add a 4. Add a 4 to this. But what's 4 going to be? It's going to be 8 over 2, isn't it? Just found a common denominator is all I did. That cancels. So here we go. Y equals negative 1/2 x. What's this going to be? What's negative 7 over 2 plus 8 over 2? It's positive 1 over 2, 1/2. And there it is. And that's the equation of a line that goes through these 2 points. So if you really wanted to, you could graph those 2 points and draw your line. But you didn't have to. All right? All you had to do was recognize what's going on. So what did I do first? I found the slope. Then after I found the slope, I stuck it into what? The slope or the point slope formula. What's cool about this, you know how I picked this point right here? I could have picked this point right here if I wanted to, and I've gotten the same exact equation, which is pretty interesting. Let me give you some problems to do. What was it? Somebody wrote it down already. What was it?
39 odd.
What to 39? 13 to 39 odd?
Wait, page 13?
No, numbers. Numbers. I don't know.
Savannah
Let me write this down.
Bianco,
Let me write this down, then I'll let you
Thunderbird,
know. It's page 200, 201. Page 200,
Justin Schmitz,
201.
Bryce McGee, Matthew